The next curve is a beautiful one. It's the ellipse, okay? And it's based upon the following idea, which is it's a set of points, the sum of whose distances from two fixed points is constant. Typically what they do is they say, hey, go to your parents' hardwood floor, tack in a couple of nails or screws or whatever, and take a loop of string or twine or whatever, and wrap it around and draw it tight, and then hold it, put a pencil to it, and then swing around these guys, and it forms an ellipse, a flattened circle. Actually, a circle is a special case of the ellipse. It belongs to that family as well. So the development of this thing, I hardly ever develop it, but I don't know, I feel like doing it today. So we have a coordinate system here. We're going to develop it. If you want to fast forward, that's fine. But I'm going to put the coordinate system up, and I'm going to say that this guy swings over to negative a in this direction, and a positive a in this direction, up b and down to negative b, and our foci, or focuses, if it's plural, they spell it F-O-C-I, by the way. Let's say they reside at these points negative c and positive c. So the first thing that you argue when you're doing this is you go, okay, the total distance from the, if you're a point on the ellipse, in fact, I should draw the ellipse, so let me do that. The ellipse is going this way and screaming around this way. Okay, pretend that's a nice ellipse, perfectly drawn, which it isn't, but pretend. And what we do is, well, let's pick the point A way over here, okay? Its distance, the sum of its distance is this one, which is tiny. The sum is equal to A minus C along the number line, and then plus this distance, and it's going to be A plus C, and the total turns out to be 2A. Okay? So that's what the total, if you've got these, what they call vertices along the major axis, let's say, A and minus A, then the total distance from any point to the sum of the distances of any point, let's put a point here now, call it XY maybe on the ellipse, the distance is, the sum of the distances to those 2 points is going to be 2A. Then you can also do it this way. You go, well, how about we go from B this way and add up these two distances? Well, you look at that and you go, well, that's a right triangle, and there's two of them, so the sum can also be looked at as twice the square root of b squared plus c squared. Do you see the hypotenuse there? We're doing this guy, but we're adding two of them together. The sum is constant, and so what we have is that sum, and what this does is it leads us to, if you can see this, get rid of the 2's. This has to be, let me do it this way, this has to be equal to 2a, which leads us to this. A squared is equal to b squared plus c squared, which is a very important identity inside an ellipse. What is A? What they call the semi-major axis distance, the distance out to the longer, the further away vertex. What is B? Well, go along this side. It's the shorter, the minor axis, and sometimes they call that a vertex, but not in this book. And then C is the distance to a focus, okay? But for us, and when we're graphing, this is the anatomy here. What we're going to do now is we're going to develop this thing, and we're going to pick this point in space. Let me get rid of some of this clutter. And we're going to go, okay, so the sum of the distances here and here from, let's say, one point is negative c comma 0, and then we have Mr. xy, and then we have this other c comma 0. Okay, we're going to say the sum of these distances is equal to, well, the simplest form would be 2a. So the way it starts out, and it's in your textbook too, but we're going to take the distance from xy to minus c0. So we get x plus c squared plus y squared plus, and now we're going to go in this direction, that distance, okay, is x minus c squared plus y squared And all of that is equal to 2a. Okay? So in order to break this out of its prison and get the form, what I'm going to do is isolate this radical here, x plus c squared plus y squared. Prepare for a lot of stinging. Prepare for a lot of algebra here in this case. Okay, we're going to have to square both sides here. We're going to have to square both sides actually twice. There you go. That's that guy. So think of yourselves as, well, I'll go this route, squaring each side. Okay, we end up with everything under the radical here breaks free. In fact, I'll multiply it out as I do so. So I'm going to get an x squared plus 2xc plus c squared plus y squared here. And then when we FOIL this out, what we end up with is 4a squared, and then it's going to be minus 2a times that minus 4a times this radical, x minus c quantity squared plus y squared, and then plus the radical squared, which I'm going to multiply out. I'm going to get an x squared minus in this case, right? Okay. The one on the left is plus. This one's going to be minus 2xc, careful Weber, plus c squared plus y squared, like so. Okay, so what happens? Well, if I try to combine terms, we're going to lose the x squareds, the y squareds, and the c squareds. They're all gone. In fact, what I'll do is I'm going to move the 2xc to the other side, and so now what we have is 4xc, right? And on the other side, we still have the 4a squared and minus the 4a, etc. Okay. So we moved him over to the other side. I'm going to keep moving stuff over, okay? So if I do that, I'll bring this over as a, well, I'll tell you what. I'll swing this guy over to this side, 4a radical. And over here I'll say 4a squared and then minus 4xc maybe. In fact, let's lose the 4's. And you know what else? Let's square both sides. Let's square both sides. So when I square the left-hand side, I'm going to multiply it out. I'm going to get x squared minus 2xc plus c squared plus y squared. And on this side, I'm going to square this thing. Okay. So we're going to get an a to the 4th, okay? Oh, wait a minute, what did I do? Oh, I wanted to also divide. That's right, that's what I do. I forget the a to the 4th stuff. I'm going to divide by 4, but also I'm going to divide by a. So let me back up. Okay, please let me back up. It's just an algebra thing to keep it nice and clean. All right, so what I'm going to do is, like I said, this is going to come over 4a radical x minus c squared plus y squared is equal to 4a squared minus 4xc. Divide by 4a. That's what I want to do. 4a and 4a. And we get the radical, okay, x minus c squared plus y squared, almost done, is equal to a minus what do we got here? The 4's disappear. We have c over ax. C over ax. Now we square both sides. X squared minus 2xc plus c squared plus y squared is equal to, squaring this side, we're getting a squared, watch this, minus cx doubled minus 2cx, okay? And then finally we have plus c squared over a squared x squared, okay? All right, so what happens here? Well, did you notice that the minus 2xc disappears? That's nice. So we're going to try to get it in that elliptical form. So I'm going to leave x squared here. I'm going to bring this crazy thing over that says minus c squared over a squared x squared. And I'm going to take the c squared on the left and bring it to the right, stand up, sit down, fight, 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 and we end up with this thing here. Just about done. What I did with the x's, I think, would be to do a common denominator. So it ends up being a squared minus c squared over a squared times x squared plus y squared, and everybody's a squared minus c squared. So the last move is to divide by a squared minus c squared to get 1 on this side. And over here on the left, you're going to get x squared over a squared plus y squared over a squared minus b squared, c squared. But you know what that's equal to? It's equal to b squared from way above. Okay. And so there you go. That's what the equation, a nice equation of the ellipse, looks like if it's centered at the origin. If it's not centered at the origin, it looks like x minus h squared over a squared plus, y minus k squared over b squared is equal to 1. Okay? Now, depending on the size of a and b, if, whatever number is bigger, that's the major axis. Let's look at a couple of examples where they're asking us to find all kinds of stuff. So it's going to be kind of long because I developed that, but maybe some of you can fast forward to this moment here. Okay, I say here, note, the larger number is under x. If the larger number is under x, then the major axis is horizontal. But if the larger number is under y, then it's vertical. You'll see that. And of course, we can shift these things like I just said. So let's find these guys. All right, so let's work on this guy first. We have a coordinate system? Yeah, we do. Here's what I do when I'm graphing these things is I go, first of all, I look for the center. It's not 0, 0. Up here, when I worked on this thing, the center is 0, 0. It's at the origin. But this one seems to represent a shift, doesn't it? Just like I wrote here. So we'll say the center in this case, just read the numbers and change their signs. So it's going to be 2, comma, look at y, negative 3, and that's the center of our ellipse. Furthermore, under x, we've got 16. So what I might do is I write this sometimes in algebra. I go, well, 16 is 4 squared. And here we got y plus 3 squared. And 36 is 6 squared is equal to 1. And that's telling me how to graph it. So I run ahead and I just graph it. I find the center, which is 2, negative 3. 1, 2, to negative 3. There's the center. And then I look under x and I see 4 squared. It's telling me to move left 4, there's a point, and right 4, there's another. And under y is 6. So I'm going to go up 1, 2, 3, 4, 5, 6, and down 3, 6, way down here. And I will draw my ellipse. Now don't laugh at my ellipse, or you're going to lose points on the next exam. That's pretty horrible. Just kidding. Okay, so that's a rough sketch at the ellipse. Okay, we could do better. Pride. Okay, every time I try to fix it, it gets worse. So give it up. Okay, there's my ellipse. But we're not done. What we want to do is he tells us up here, find the vertices. Well, the vertices are staring us in the face. The vertices are along the longer axis, which is this way, isn't it? Because that was a longer distance. So there's a vertex and there's a vertex, and we tell the world the vertices are, and then there's different ways to do it. I noticed the book does this. The x value doesn't change, it's 2. But then you go to the center, which is negative 3, and you go plus minus 6. You might want to do something like that. And it works like a charm. You start at the center, you go up 6, you go down 6. The other part of this for an ellipse is we're supposed to find the foci. Okay, the foci are, and we have a little bit of work to do. Okay, they're going to be along the major axis. I'll put this in red so we can just differentiate that stuff, so to speak. Okay, remember, okay, so in this case, the longer piece, if you want to call it A, that's fine. Okay, and so we're going to say b squared plus c squared is a squared. Well, the big boy is 6 squared. The little guy is 4 squared. And the guy we don't know is c squared. So c squared is 6 squared minus 4 squared. So c itself is the square root of 36 minus 16, square root of 20. Okay? Not quite 5, is it? And it's nice to do this for Weber, 2 radical 5. So whatever that ends up being, square root of, it's not 5. So I'm going to guesstimate it here for fun, going about 4 point something and about here for fun. And we'll say the foci are, once again, 2 comma minus 3 plus minus 2 radical 5, and we're done with the problem. Okay, a little bit of talking there, a little bit of work, but being able to find this stuff pretty quickly, pretty good. All right, so here's one where it's not, you gotta complete the square in this case to get it in that form. After all this work up here, I feel we've earned the right to just simply put it in this form here and graph the darn thing. So let's do that. All right, so what we do is we separate the x squareds, put them together, plus 40x, and then plus 9y squared minus 90y, and then equals negative 65. And we go about completing the square. To do that, what we have to do in our case is factor out a 20 from the x's. So we'll go x squared plus 2x, and we'll complete the square there in a moment. And we do the same thing for the y's. We're going to take out the 9, and we're left with y squared minus what? 10y, okay, is equal to negative 65. Now, when you complete the square, you're going to add numbers inside the paren. So in this case, half of 2 is 1 squared is 1. You didn't add 1 to the left, you added 20 times 1. So on this side, we also add 20 times 1. When we complete the square with the y's, half of negative 10 is negative 5. Negative 5 squared is 25. But you didn't add 25. What did you add? 9 times 25, which is a big number. What is that? That's, what is that? 225, I believe. So look what we have now. We've got, I like this color for some reason. I'm going with it today. I think it's just I'm in a burgundy day. I don't know. So we have 20, and then we have x plus 1 squared plus 9, and y minus 5 squared is equal to whatever's over there. That's 245. So it's looking like it's 180. Divide by 180, and you've got x plus 1 squared. 20 over 180 is 2 over 18 is 9 down there, huh? Plus y minus 5 quantity squared, and then 9 over 180 goes in, what is that, 20 times? Is equal to 1. Okay. If you want to just find everything first, you can do that. You can say the center is, now actually I'm going to graph it. The center, it looks like it's negative 1 and 5 this time. So we cruise down here, go negative 1 and up 5. Unfortunately, it's way up there. My scale is not so good on this thing. We could change it if you wanted to. And then we're supposed to go left, right, 3. And up, down, a radical 20, which we just messed around with, which is 4 point something or other. So cruising down to about, oh, I don't know, here and up here. And once again, we've got a tall ellipse doing its thing like so. Okay, this is again the major axis. And so somewhere along there is going to be our foci. So we're almost done. We can list the vertices if you want. The vertices are here and here. So down here at the bottom, we'll say the vertices are, and then I would say the x value is negative 1, not changing. The center is 5, and then you're going to go plus and minus. I think it's 2 radical 5, isn't it, in that case? So you went up and down that far. And the last thing to talk about are the foci. And they are also going to be minus 1 and 5, plus and minus. We just have to find the c. Okay, well, what we found last time was c is equal to the square root of the square of the larger and the smaller, right? Is that right? No, the larger one minus the smaller. It's right here. So we're going to say 20 minus 9 square root of 11. And that guy is about, well, it's 3 point something or other. So about here, and down here we'll just say square root of 11, and we're done. Okay, so doing the homework here is like doing pre-calculus stuff. And that's the full story of the ellipse as far as I know. And we'll see you for the hyperbolas.